We now step up again from the teenager problem to the adult problem, which is to solve the path integral for scalar field with an interaction. When we solve this integral for lambda equals 0, we first rewrote it in a more recognizable form of a Gaussian integral. If we now compare to what we had for the teenager problem, we can now process by analogy using the fact that the teenager problem is just a discretized version of the adult problem. We have n integrals, which becomes a path integral. We have a sum over j and k, which now becomes two continuous integral over x and y. We have qj becomes phi of y, ajk a y minus x, qk phi of x, etc., etc. So we can just use the results for the teenager problem and take the continuous limit of it in order to get a reformulation of the adult problem. The derivatives with respect to j in the discretized case becomes functional derivative in the continuous limit. They can be seen as standard derivative, but with respect to a function evaluated at some specific variable w. The second exponential is simply obtained by solving the Gaussian path integral for free fields. Therefore, the propagator d is just the Klein-Gordon propagator we had in the case of free field theory. So we managed to rewrite a path integral which we didn't know how to solve into a new expression involving exponential of derivatives, and we still don't know how to solve that because we have an infinite terms to take into account in the Taylor expansion of this exponential. So it's only going to be useful in perturbation theory where we can only keep we can truncate the Taylor expansion for this exponential, so up to some order in the interaction strength lambda.